The depth of the water in meters in a harbour on a particular day is modelled by this equation, and we're told that t is between 0 and 24. T is the number of hours after midnight. A boat enters the harbour at 6:30 a.m. and it takes 2 hours to load its cargo. The boat requires a depth of water to be at least 3.8 meters before it can leave. And then we want to find the depth of the water when the boat enters the harbour. Okay, so when the boat enters the harbour, we're told the time is 6:30 a.m. So if we look at our equation, d is equal to 5 plus 2 sine 30t. T is in hours between 0 and 24. So then if our time is 6:30 a.m., then t would be equal to 6.5, 6.5 hours. And then d would be equal to 5 plus 2 sine 30 times 6.5, which gives us 4.48 meters. Part B. Find, to the nearest minute, the earliest time that the boat can leave the harbour. So, for the boat to be able to leave the harbour, it says the depth needs to be at least 3.8 meters. So d needs to be bigger than or equal to 3.8. The depth is equal to 5 plus 2 sine 30t. So this needs to be greater than or equal to 3.8. So we want to solve this inequality and work out the earliest time that the boat can leave the harbour. We know the boat enters the harbour at 6:30 a.m. It takes 2 hours then to load the cargo, so we already have a restriction as to what t can be. T has to be 2 hours after 6:30 a.m. Remember that 6:30 a.m. is when t is equal to 6.5. 2 hours after that, so t has to be greater than 8.5 at least. So we want to find the first value of t that satisfies this inequality, depth being greater than 3.8, and also satisfies the time being greater than 8:30 a.m. So looking at this inequality here, let's rearrange that. We'll take away 5 from both sides. We end up with 2 sine 30t is greater than or equal to minus 1.2. We can then divide both sides of that by 2. We get sine 30t has to be greater than or equal to minus 0.6. And to solve this inequality, I'm going to use a substitution. I'm going to say let theta equal to 30t to make this easier to solve. So we get sine theta is then greater than or equal to minus 0.6. We know that t has to be greater than or equal to 8.5. If I times that by 30, 30t needs to be greater than or equal to 30 times 8.5, which is 255. And that's the same thing as theta needs to be greater than or equal to 255. Okay, so our goal now is to solve this inequality for theta has to be greater than or equal to 255. This inequality, when we solve it, we end up with the solutions for time for when the depth is greater than or equal to 3.8. That's how we got that inequality in the first place. So once we've worked out our theta values, we can then use theta is equal to 30t to then convert them into times. Okay, so let's start with equating sine theta to minus 0.6 and then figuring out when theta is actually equal to it. So I get theta is equal to minus 36.870 degrees. So this is our principal value. Now, without having to draw the graph, we can always use this rule. Whenever we're doing inverse sine of a number and we end up with our principal value, we can then do 180 minus our principal value. So 180 minus our principal value, whatever that might be. In this case, it's minus 36.870. That will give us our second angle, which is 216.870. And then with these two angles, minus 36.870 and 216.870, we can then add or subtract 360 as many times as we need to find all the other angles in our required domain, which in our case is theta has to be greater than 255. So why is this the case? Why can we do 180 minus our angle? Let's draw a sine graph to represent this. So here is our sine graph. I've drawn it between minus 180 and 360. And then we have our solution over here. So this is our principal value, minus 36.9. When theta is equal to that, sine theta is equal to minus 0.6. And then to find our other angles, we can then draw a line across and then see where it intersects with the sine curve. So that would be here and here. So this angle here, to work that out, we use the symmetry of the graph. If minus 36.9 degrees is 36.9 degrees from 0 towards the left, if we add that same angle, 36.9, to 180, we end up with this angle. So if we did 180 plus 36.9, we'd end up with the exact same angle that we have here. So this rule will always work. Another example, let's say our principal angle happened to be 60 degrees. So 60 degrees would be over here somewhere. So then to find our next angle, we go across to here. If we did 180 minus 60, that would give us our next angle. Okay, so now that we have our first two values, we can add or subtract 360 to these to get our angles in this domain. I'll put that on the right hand side. So 360 plus this angle will give us the angle that we have over here, as we have one full sine oscillation between this point and this point. There's 360 degrees between those 2 points. That gives us 323.13 degrees. Okay, so this is our first angle that is above 255. Remember that when sine theta is greater than or equal to minus 0.6, that's when our depth is greater than or equal to 3.8. So we can represent that on our graph. Minus 0.6 is what we have over here. So then these regions would be when the depth, and we can continue the graph as well if you wanted to, so that will just continue on. Those regions would be when sine theta is greater than or equal to minus 0.6, and therefore the depth is greater than or equal to 3.8. Angle 323.13 is bigger than 255, and it will be the start of this region here, where sine theta is greater than minus 0.6, and therefore that angle of theta should correspond to our first time when the boat can leave the harbour. So if we then use theta is equal to 30t, or t is equal to theta over 30, divide 323.13 by 30, and we end up with 10.771, and remember that t is in hours. So that's our time, but we want it in the nearest minute, so we need to convert this into an actual time. We can do that by considering the 0.771, that's the proportion of an hour that we have after the whole number of 10 hours. So we times this by 60, which gives us 46.26. That's the number of minutes we have on top of those 10 hours. So our time would then be 10:46 a.m. And that will be our final answer.